everybody, we're back. I'm Bridget.
And I'm Mike.
And this is Soft Magnetics.
Hard Topics.
First, we want to congratulate our lucky YouTube subscriber that won, Mikhail. Congrats. I hope you enjoy your Nano VNA. And maybe when we hit 5,000, we'll give away something else.
Yeah.
Feeling generous. So today we're going to make sure you're not bored. Just kidding. We're going to talk about board components. So let's talk about the most popular, which I think is the most popular, is chip beads.
I mean, certainly by numbers sold, but...
Well, if they're that small, I would think.
They're also rather tiny. So this is
what we call a chip bead. So that's going to be a multi-layer chip ferrite bead. So there's an internal winding structure inside of that. They're all differential mode. So they have 2 leads on them. Leads, they're surface mountable parts. Different sizes from 0402 up to, I forget what our largest is, but quite large. This is kind of middle of the road one that you just saw.
So even smaller.
Yeah, quite a bit. They get quite a bit smaller and quite a bit bigger than that. The impedance performance on them is going to be dictated by a couple different things. So the internal winding structure of them is going to dictate part of that impedance. The other part of it, kind of similar to our cable cores, is going to be the material grade. So they're all varying types of nickel zinc ferrites, but that can help tune it towards higher or lower frequency operation. They're all impedance rated. The internal winding structure on them, in addition to changing the overall impedance values, is also going to affect the maximum current that they can operate at.
They're just like soldered on, glued on?
Yeah, they're surface mountable parts, SMT parts.
Duh.
Yep.
Okay, so then we have surface mount beads.
The next step up.
Woohoo!
Yeah. So this is another surface mountable part. It differs in that the way that the surface mount beads are constructed is with a multi-layer ferrite and then screen printing in what we call a co-sintering process. The surface mount parts, so these are wound actually. So this is a normal pressed and sintered ferrite that then gets a winding applied to it. This one in particular that I have in my hand is a surface mountable one. It is common mode. So both of the leads that are on this one are passing through the same aperture. We also have them in differential mode.
Yeah.
Yeah.
I know.
With 2 leads as well, or with just a single lead on them.
Mm-hmm.
And these are going to perform a lot more similarly to a cable core. So if you were to say, put a cable core on one of our snap-it cores or something like that, on a cable, and then you wanted to transition it to an onboard component, along that same electrical path that you put the cable core on. If you were to put a common mode surface mount bead on there, you can expect to get pretty similar performance to one of the on-cable cores with something like this. Since the materials will be the same.
Do they get as big as a cable core?
They don't need to. So kind of the interesting thing with these, since you're only using, basically the magnetic path length on these cores, because they're so small, shrinks a lot, and that drives the impedance value back up. Whereas cable core, even though it's physically a really large core, it has a pretty large magnetic path length, and the larger that magnetic path length is, it drives down the impedance value. It's compensated on the cable core by having a big cross-sectional area. This has a small cross-sectional area, but it also has a small path length, so the impedance performance can be actually pretty similar between the two.
That's cool.
Current handling wise, these typically will handle more current than something like a chip bead. If you're looking for like a reason why you would use something like that versus a differential mode chip bead. So you'd use a differential mode surface mount bead in place of a chip bead if you had to handle higher current, for example, or you needed a extremely low DCR. So these are typically 3 turns maximum on these types of cores. So the DCR is extraordinarily low on them.
Okay, so we want to keep with the square shape.
Keep going square.
Square.
PC beads.
So these are kind of a little bit of an interesting one, PC beads.
So these are typically, they're similar in construction to the surface mount beads in that this is a pressed and sintered ferrite core with a, I guess if you could call it a winding applied to it. It's not really a winding in that it's just kind of a U of wire shot through a few places. So these are also differential mode, exclusively differential mode beads. And they are through hole. So the way these would work is each lead pair essentially goes through the core, around, and back through the core again. Magnetically, it would be almost the equivalent of having 2 like EMI suppression beads along a wire. It would give you kind of similar performance to that. So pretty broad band, fairly high impedance values. Some of the more highly wound parts won't be quite as broadband, even though they will have really high impedance. So yeah, for through hole, that could be a pretty compelling option.
Cool. Bead on lead.
Bead on lead.
BOL.
BOL.
So this one is actually very simple. So this is essentially a leaded version of our what?
It's a bead on lead.
It's a bead on lead. Yeah, the name's pretty self-explanatory.
What? No way.
So it's a surface mountable ferrite bead that, or not surface mountable, a through hole radial leaded ferrite bead, and basically it's the same as our normal EMI suppression beads. Just we applied the lead already to it, so it's ready to be mounted.
But do those get bigger?
They do get bigger.
Cool.
And different materials, and it's a pretty simple part.
We like it.
Yeah, works well.
And then we have wound beads.
Wound beads. So these are, I guess, kind of almost halfway between the PC beads and the bead on leads. So this is, again, a pressed and sintered ferrite core. And what we do here is we pass through a cable or a single conductor a bunch of times on here. I think we have a few that use multiple conductors too, but they're all differential mode. The way these work is, again, magnetically, it's pretty similar to the PC bead in that you're looking at essentially a stack of individual, again, the equivalent of it. The individual kind of bead on lead or EMI suppression beads along a single conductor is magnetically what this would look like. Since there are so many windings on this, what you wind up with is a pretty high impedance part, but with still a pretty broad band frequency response. And that's because, each winding of the conductor is going through its own kind of magnetic path in there, so you're not getting all that parasitic capacitance from the different windings like you would on something like a wound toroid. But these are all through hole, I believe. Yeah, all through hole components.
Is there a reason why this one has it coming out each end and that one's the same side?
So you can do like kind of fractional turns on these.
Okay.
So if you want to do a full, like kind of 2 turns, if you will, it's going to come out the same side. If you want to do a half turn, then you'd have it come out the other side.
A loop-de-loop.
Yeah. We also have these kind of radial or axial, depending on what makes more sense for how you want to mount them. So they'll change based on that too.
I like them.
Yeah, they're fun. Kind of a unique product.
Yeah. So is that covered most of our board or all of our board components?
I think that covers the majority of them. I mean, all the board components are going to be some kind of permeation of these basic
Types, yeah.
So, I mean, there's surface mount beads that have, rather than these kind of flat, squarish conductors, we have ones that have a round wire conductor on them. You know, PC beads that have only 2 conductors, some that have 5, 6 conductors on them. Wound beads that have multiple leads coming off them, or multiple conductors, so you're using it as 2 differential mode chokes at the same time. But yeah, they're all kind of one of those basic types.
And a lot of them do come in engineering kits. We have like little bookshelf kits where we give you sampling of these different types of, there's chip beads, there's some beads.
We should probably discuss how these things are actually packaged too a lot of times. So these are available kind of bulk pack or tape and reel. They're all ROHS, lead-free. Kind of.
I think it depends on the part number. So if how they're packaged. So
yes,
there's 2 different numbers. It might be the same part, but just packaged differently.
Yes.
Very cool.
Yeah.
It's been a big project. A lot of people, you know, chip beads are always a big request that we get. So if you're interested, check out our website. We cover all of our components and board components on there. And if you need an engineering kit, they're on our website as well. So
yeah.
Well, thanks, Mike, for going over it with us. We definitely weren't bored. I guess we'll see what we could come up with next. I think we got some stuff in the works with some new devices that we might have received. So stay tuned, comment what you want us to cover next, and we'll see you soon. Bye.